Hey Block 2 students. So this is a solution video for this week's problem of the week in which you have to think about marble madness. So this is a pretty fun task, I thought. So this came from the website Open Middle. If you Google Open Middle, you'll see there's like a whole website devoted to problems like this. And the idea is that we ask students to just do one problem instead of a zillion. And that one problem really gives them opportunity to think about and engage with a particular math idea in the same kind of way that we would hope that they learn from homework, but in a way that's a little bit more interesting. So here's how I did this problem. So the first thing I tried was just thinking about it as small numbers, big numbers, and medium numbers, and trying to think about it, well, maybe it's big minus medium equals small. So like 987 minus 654 equals 123. The problem is that doesn't really work. And what I found is that I couldn't find any solutions that didn't involve borrowing. So if you found a solution where you didn't have to borrow, I would like to know about that. But so then my second thing was like, well, I'm just gonna get some number cards and swap things around and see if I can make it work. So by doing that, I've actually come up with quite a few solutions. So here, I'll hold these in front of the camera. Maybe you see your problem. Do you see the problem that you found? So as you can see, there's actually quite a few problems that work with this. So check and see, are any of the ones that you found listed here? If not, that's fine. I'm gonna show you how I've been generating these. So the first thing that I've been doing is just thinking about, first of all, what do I need in order to make this happen? So the first thing that I know, so here's my kind of like grid, right? So this number minus this number will equal this number down here. So the first way I've been thinking about it is, first of all, in my hundreds place, I need a bigger number here than here, right? So if, for instance, I had 7 there and 3 there, I'm gonna get a negative number, and I think that might make things wonky. So instead, I'm choosing to always have a larger number up here than down here. Okay, so that was the first thing I was thinking. The next thing I was thinking is, what are some combinations that are probably not gonna work? Well, one of them would be something like an 8 there and a 4 there. So why wouldn't that work? Well, because I'm gonna need another 4 here. So, and I only am allowed to spend 1 4. So same thing, if I had a 6 and a 3, I would need a second 3, and I don't have a second 3. So that made me think, well then I'm never gonna have a situation where the middle number is half of the top number. However, I found a solution to that, and we'll talk about that in a second. The last thing that I initially thought of was that I'm never going to use the 0, because let's think about it. If I had like a 4 here and a 0 here, well then I need another 4 here, right? Actually, I found a way around that. So once the way that I started doing these is basically just dealing out the cards and then seeing if I could adjust. So there's my cards, and I'm just going to leave the 7 out. So I want you to look and see, can you see any quick swap arounds that would make this true? Okay, so the first problem I already see is in my ones place, I have a double, right? So 3 is half of 6, so that's not gonna work. So let's do some swap arounds. All right, so this obviously isn't true, but let's see if we can arrange things. So I'm gonna work my way over from right to left. So 6 minus 4 is 2, all right? 8 minus 3 is 5. So far so good, right? But then we get over here, 9 minus 0 is not 9. So here's that trouble spot I'm finding. I would need a second 9, and it doesn't work. Well, can I swap in the 7? No, not really, but we're getting closer, right? So then I just start swapping things around if I can figure it out, and see if I can figure it out. So my 9 minus 7 is 2. So could I make this 6 minus 4? That makes a 1. 8 minus 4, oh, that's not gonna work. So there I have my trouble spot again. So one thing I want you to notice about these numbers, we are not asking of any borrowing. So like I said before, I haven't actually been able to find a solution that doesn't require borrowing. And so in this case, we could think about borrowing as being this number down here has to have at least one digit that's bigger than the digit above it, which would prompt us to borrow. So for instance, if it was 985 minus 736, this is going to make us borrow. Now I want you to think about what's going to happen when we borrow. So when we borrow from the 8 to make this a 15, this guy's going to turn into a 7. So what I started to think about, here's how I started to think about this. It's almost like when I make a problem that requires borrowing, I purchase a new card. So in this case, I'm spending my 8, but look, when I borrow, I get back a new number 7, right? Because if I did 15 minus 6, or if I did 5 minus 6, well, I needed to borrow, so I cross this out and it turns into a 7, and then I get a 15 here. So suddenly I have a new 7. So that helped me start thinking about how I could be strategic with borrowing. So let's try this again, now that we have a problem that's going to involve borrowing. That's not to say that I didn't try it a lot of times without needing borrowing, I just couldn't make it work. So I don't have any proof that it doesn't work, and maybe you found one that does work, but this is how I started to think about it. So 15 minus 6, so that's going to be 9. Well, I can't put the 1 there, right? Because then I get a negative number, so I'm going to switch these guys. So 15 minus 6 is 9, and then this turns back into a 7. Well, 7 minus 3 is 4. 7 minus 1 is not 2. So we have a problem again. So let's just swap this out. And this is basically how I started thinking about it. It's just swapping around. So 12 minus 6 would give me back a 6. That doesn't work, so I can't have a 6 there. 12 minus 3, however, gives me a 9. 8 minus 6 gives me back a 2. Ooh, but remember, once I borrow, this turns into a 7. So 7 minus 6, that's a 1. And then, let's see, I feel like I'm getting close, but not quite. So let's see, 7 minus 4 is 3, so that doesn't work. Let's just steal the 3. So 12 minus 5 makes a 7. 12 minus 5 is 7, and then this is turned into a 7. 7 minus 6 is 1. And then 9 minus 4, well, that doesn't work. So let's steal the 5. This is basically all I did. I just kind of went around and around in circles until I would find something that works. 12 minus 3 would make a 9. Oh, I think I've actually just come all the way back around full circle. So this might not work. Let's see if we have to borrow here also. What happens if we do this? So 12 minus 3, that gives us, no. So let's swap this guy again for, let's see what happens now. 15 minus 6 is 9, okay. And then this becomes a 7. 7 minus 4 is 3. And then 2 minus 1 would be 1. Okay, so that's a problem. So now I'm going to think about, what if I swap these guys? Like that. 14 minus 8 makes 6. And then when I steal from the 5, this becomes a 4. What if I make myself borrow again by making a number that's bigger than 4? So 14 minus 9 would be 5. Oh, that doesn't work. So 14 minus 7, that would be 7. 14, okay, well, let's just go back. 5 minus 3 is 2. So this is basically just all I did. So I'm just going to be quiet now and work on it. Maybe you see an obvious solution, but I'm just going to try and swap things around until I find something that works. Minus 9 is 9, so that's not going to work. 17 minus 8 is 9. This is a 3. 3, 13 minus 6 is 7, so that's not going to work. This is 1. And then so you can see I don't have any systematic way necessarily of doing this, but I know when to stop, and that's just when I get something right. So let's try this. Makes this a 17, minus 8 is 9, then that makes this a 0. So 10 minus 2 is 8, so that's not going to work. 10 minus 6 is 4, and that makes this a 2. 2 minus 0 is 2. Bah! I found one! Woo! Okay, so let's see if we're right. 7 minus 8 doesn't work. So I turn this into a 17. So this is now a 17. 17 minus 8 is 9. And I got that 17 by borrowing here, right? Well, now I need to borrow again because 0 minus 6 doesn't work. So I take 1 from here. And this is now a 10. 10 minus 6 makes 4. 2 minus 0 is 2. So let's look at some of the things that worked out here that I thought initially wouldn't work out. First of all, you can have a 0 in this row, but it just needs to be strategic. You need to think about that I can have a 0 here if I end up crossing this number out, because then I purchase 1 back. I basically created a 2 where there wasn't a 2 before, which let me use my real 2 down here. So how long are we? We're at 11 minutes. So that's pretty much the way that I solved this. So one thing I want you to think about is how much stuff I had to think about in order to get a problem that worked, right? So the problem I ended up with 317 minus 68 makes 249. So think about all the things I had to think about. I had to think about which numbers would make me borrow. I had to think about how I can't have a double. All those things draw on students' number relationships in really smart ways, where them doing one problem and trying a number of times, even failing a number of times, and then being asked to think about why they failed, can actually buy us a whole lot more of instructional opportunity than just making kids do 50 problems that are the same. So I want to challenge you to go to Open Middle, go to the website Open Middle, and think about what would it look like to assign your students just one problem for homework from Open Middle instead of 50 problems where they're practicing the same thing that's predictable over and over, and instead do something where there is no predictable way to do it. You just got to think about it, and by thinking about it, we're drawing on students' understanding of things like borrowing, things like carrying, and things like number relationships between the digits. All right, see you sometime soon. I hope your field placements are going well.